Okay, hello everyone. Welcome to the third week of our pre-calculus class. In this class, it'll mainly focus on trig, polar equations, ellipses, and the 3D coordinate plane. But let's actually first start with a quick review of the concepts from our last class. Um, okay, so I hope you guys still remember these concepts. Okay, let me see. Yeah. The first formula, this is the simple area formula for triangle ABC with, if you know two side lengths and the angle between them, then you can calculate the area. And this is shown over here because, for instance, let's say we know these two side lengths. This one is A, that one is B, and the angle between them is angle C. So then, as shown on this graph, then this height over here becomes B sine angle C, and thus the area of your triangle is 1/2 base height, base times height, which is then equal to 1/2 AB sine angle C. Okay, so this is a simple formula for you guys to remember. This is all review from our last class. Um, okay, our next concept, law of cosines. So law of cosines is useful if you have two if you have an angle and a two side lengths right next to that angle. For instance, like let's say if you have these two side lengths, and again, like I'm just gonna call this angle C. So then we can find out the mystery length, like what is this length? So we can actually find it out directly using law of cosines. And it is written right here. It's a squared plus b squared minus 2ab cosine angle c squared root that. Law of cosines, there's also another way to use it. For instance, let's say if instead we do not know the angle C, but what we do know is, okay, what we do know is the length of the three sides, but what we don't know is this. Okay, so can anyone tell me how you would try to get this angle using law of cosines? If you have ideas, like you can type it in the chat to one of the TAs. Okay, does anyone have any ideas yet? You can also raise your hand. Let me see, rearrange. Okay, yes, Larry. Yeah, that is exactly what you would do. So you would try to rearrange the formula, because we can just like reformat this equation to instead become cosine angle C equals to a squared plus b squared minus c squared over 2ab. And this allows us to compute what a cosine of angle C is. And well, oftentimes that's enough for like most problems. I suppose if the problem asks you to solve directly for what angle C is, then first of all, you'd have to take the arctangent of, wait, no, arccosine, sorry, what am I saying? Then if like it asks you for an exact measure of angle, then you would need to take the arccosine of a squared plus b squared minus c squared over 2ab. But then oftentimes, yeah, okay, yeah, that's it. So basically, yeah, you actually do not need to care about obtuse and acute angles because cosine, if it's obtuse, then negative. So yeah, that actually does not matter. Yeah, so either way, this formula actually gives you a nice way to get the exact value of the angle. Okay, so on to the next one. The next one is about law of sines. Okay, so law of sines, I'll quickly go over it and where it comes from. So I believe last week it was probably already taught in class, but wait, shoot, I should draw a better circle. Hmm. So when you have a circle like this, and you have a triangle ABC within the circle, so over here, the length R is defined to be the radius of the circle. For instance, this length is R. But either way, so and okay, the lengths of the triangles are labeled A, B, and C. And basically the formula states that A over the sine of the opposite angle is equal to 2R. So as for why this is true, the proof is actually quite simple. So do you guys know what circumferential angles are? Okay, I'll assume you know, but either way, so this is something if you don't know, you should definitely note down. Okay, I'll just like write it up here. Uh, what is wrong with my pen? Uh, Circumferential angles of an arc on a circle are all equal. Okay, shoot, because I cannot write up here, I'll just have to type it out. Circumferential angles of the same arc on a circle are all equal. I will quickly draw out an example for this. For instance, imagine you have a circle like this. When I say circumferential angles of same arc, it's basically, for instance, like let's say this is the arc I'm talking about. Okay, then any angle that's circumferential to it, like this angle, all of these are all equal. Okay. Okay, so as for how we will apply it here, to prove this law of sines, basically, what we would do is we would extend this length over here, OB, like what I call O, the center of the circle, extend OB past point O. So this is a diameter, right? Diameters have length 2R. So the total length of this thing is 2R. And so now can someone tell me what the angles are within this triangle? Let me highlight it. Shoot. Yes, here. Can someone tell me what the angles are within this triangle? You can type in the chat or just like say it out loud. Oh wait, does anyone know what the angles within this triangle would be? Like, it's okay if you just like know one of the angles. It's like you can just say it out loud. Um, like it's just using circumferential angles. Okay, but if you guys don't know, so I'll just say it here. First of all, can someone tell me what this angle is? This angle is the angle like opposite to arc BC. So it's basically sort of the circumferential angle of arc BC. But we already know the circumferential angle of arc BC because we have this one, right? This is also the circumferential angle of arc BC. So then these two have to be equal. And then there's also the other property because this is the diameter of a circle. The angle opposite to diameter is always 90 degrees. Okay, I'll also write that here. Angle opposite to diameter of a circle. Yeah. So this angle is 90 degrees. This is angle A. Then now can someone tell me what a BC is? Because we already have this triangle. This is length 2R, angle A, 90 degrees. So what is BC? Okay. BC is equal to 2R times sine angle A. So that's actually how we prove it, or just equal to side length A. Okay. But then that's actually how the law of sines is proved, and that's why these three terms are all equal to the 2R term. Okay. So if none of you have any questions on this, we'll move on to the next slide.
Oh, okay. So this is slide is about so first we have Heron's formula. I think this should be a this should be this should be a review. So basically it basically states like if we have like wait oh wait okay so if we have like a triangle uh okay what so if we have like a triangle let's say like A B C and this is A. This is B, this is C. Basically, if we have S as the semi-parameter, A plus B plus a C over 2, then like, oh wait, so basically like, uh, so basically like we have S equals, if we have S equals the semi-parameter, then we just plug in, then we get the area. The proof of it, so like first we know that like the area. Okay, sorry. Well, I'll just type instead equals BH over 2. So we know area equals base times height over 2, right? And then let's say like we have A as the base. We want to calculate the height. I'm sorry. We want to calculate the height, let's say from A to BC. So let this be H. And then like we want to calculate H. So then first of all, we set up some quadratic equations. So first of all, if we
Kennan,
let like
wait, Kennan, do you need me to open a new whiteboard? I can like quickly open a new
uh
whiteboard if you need one.
yeah, probably just open
But
whiteboard.
yeah, it seems we're running out of room. Give me one moment. Share more, just a whiteboard. It's taking so long. Screen. Ah, yes. Okay, so here's a whiteboard.
Oh, okay. So let's okay. So basically, let's see. We had like come on. So like we had like a triangle. Say like A. All right. So basically, we had actually now I'll just use law of cosines to prove it. But because we talked about law of cosines earlier. But anyways, so a law of cosines basically states that cosine, as Alex explained earlier. Oh wait, I'll just type out cosine C um equals B squared plus B squared minus C squared. C divided by 2AB. All right. So and then we also know area equals 1/2 times AB times C. Yeah. So anyways, wait. All right. We also know by Pythagorean theorem that sine angle C is because it's basically so sine C is equal to square root of 1 minus cosine C squared. So so like basically we plug in what we had earlier from law of cosines. So that's uh 1 minus actually I'll make it longer. Wait. No wait. The square root of 1 minus a plus b squared minus c squared over 2ab over 2ab. I'll put this one. But I think this should be right. So then we know that by difference of squares, we know by a difference of squares that this is 1 minus the cosine squared. So we know this is 1 minus cosine c, uh, 1 plus cosine c. And then plugging this again, in again, we get this is square root of, let's say, let me calculate. Yeah, this is the square root of 2ab, 2ab minus a squared, minus b squared plus c squared. Uh, yeah, over 2a, times, 2ab plus, squared plus b squared minus c. That should look good. So, okay. Okay, now, we can note, we can group these terms. So first of all, note this part, let me highlight this. This part, is equivalent to, this part is equivalent to a c squared, minus a minus b squared. Let me square root of this. All divided by 2a. And then we multiply this side is a plus b squared minus c squared over 2ab. Okay, so let's evaluate this. So basically, we basically can factor out 1 over 2ab. So because we both have 2ab here, and we also have 2ab here. So basically, this equals 1 over 2ab. And then here's square root. And then note that, like, for c squared minus a minus b squared, we can use the difference of squares again. So that's c minus plus b, c minus a, c plus a minus b, times a plus b squared minus c squared is a plus b minus c. And then I think it's, okay. So, yeah, wait, let me see. Yeah, change this. Wait, no, that's right. And then times a plus b minus c. Okay, and then all divided by 2ab. So basically, we know this is equivalent to this all over 2ab. And then we substitute the semi-parameter. Also, so okay. Note s minus a equals b plus c minus a over 2, where these are in parentheses. S minus b equals, well, a plus c minus b. You can basically guess from so on and so forth. Okay, so then plugging this in, we basically know that this is basically plugging it back in. We know that area equals 1/2 AB times 1/2 times sine of C. So plugging this in again. So this equals 1 AB times AB over 2 times 1 over 2AB is 1 over 4. So this part becomes 1 over 4. And then square root of, note this is 2 times S minus A, 2 times S minus B, 2 times S minus C. Then we have A plus B plus C, which is basically 2S, all over 4. And then note this is a square root of 16S, S minus A, S minus B, C, over 4. And basically we arrive at Heron's formula. So basically, that's how we use a law of law of cosines to prove Heron's review. You can copy this if you want. So anyways, I think this should be proof Heron's formula. Wait, Alex, can you return to the,
Yes.
yeah. Oh, oh, so here we are. So anyways, we have area equals S. Oh yeah. Okay, so basically we just proved Heron's formula. Okay, so we'll I don't know. Yeah, I'll just prove angle bisector theorem. It's pretty short. So basically, as shown, angle bisector theorem basically states if we have like the angle bisector of an angle, say over here, then the opposite side of the triangle, which is this length, uh, they're divided into two segments, C and D. Then we know the sides are proportional to the segments. Oh wait, okay, only. Uh, so basically, I think I'll just prove it. So basically, we extend this angle bisector, then we construct a line parallel to it, let's say. All right. So as marked already, the two angles are equal. So, and since we have the parallel lines, we also know it's also equal to this angle. So we know this triangle is isosceles. Let me undo my drawings. So basically, we know this point, this point, and this point is isosceles. So this length is B also. Then we know we have similar triangles. So I'll try to highlight it in like red or something. So these two triangles are isosceles. Note we have A as the side length here and B as the side length. So their ratio is A over B. And then note their ratio also equals C over D because it's the corresponding lengths. So basically we get A over B equals C over D and we're done. And yeah, I think this should be this.
Yeah. Okay, now we will go on to one of the first review questions.
Um, okay, so now that we've reviewed some of the formulas from the last class, we can work on some problems. So for this first one, we have a triangle ABC with AB equals 4, AC equals 3, and angle A measuring 60 degrees. So, so try to use the formulas from the first two slides to find this one, and you can send your answer in the chat.
Okay, yeah, Sarah, the answer is correct.
Mm, okay, so you can find the area by using the formula on the first slide, which was uh so okay, wait, let me get it. Okay, so the area of triangle ABC is going to be 1/2 times uh, AC times AB times the sine of angle A, which is 1/2 times 3 times 4 times sine 60. This is root 3 over 2, so this will become um, 6 times root 3 over 2, which is 3 root 3. If you forgot the area formula, you can also rederive it by dropping this perpendicular. Uh, and then this will be 3 sine 60 degrees. And you can use base times height over 2. Yeah.
Sorry, give me a moment. I'm having a little technical. Wait, wait, this is not working well. Okay, so next question. Given that a triangle ABC has these lengths here, so find angle B. Okay, does anyone have any ideas about how to approach this problem? If you have any ideas about this, so then you can directly send them to me. Like, even if you don't have the answer, like if you have an idea, for instance, like you know what formula to use, even down. Yeah, law of cosines. That's correct. So over here, how we use law of cosines. So remember earlier, I said that we could change the formula for law of cosines, like we just like move the terms around. Then cosine angle B is going to be equal to a squared plus c squared minus b squared over 2ac. 3 squared plus 8 squared minus 7 squared over 2 times 3 times 8. 73 minus 49. Okay, so that's 24 over 2 times 3 times 8. That's 1/2. So cosine angle B is going to be equal to 1/2. Can anyone tell me what angle this would be? So what is angle B? You could express it in radians or degrees. No, it's not 45 degrees because let me show you. If you had 45 degrees, cosine of 45 degrees is actually equal to 1 over square root 2 because 45, 45, 90, this is 1 root 2. So no, it is not 45. Okay. 30, wait, no, it's not 30 either because 30, but you're really close because if you see 30 degrees, the angles here are 1 root 3, 2. So cosine of 30 would be root 3 over 2. Sine 30 is 1/2. Yeah, so like you're really close, but like I think you just swapped two angles. Who else answered? Yes, 60 degrees is the right answer. Because let me show you. So 60 degrees, 30. So this right triangle has side length ratios 1 root 3, 2 like this. So yes, angle B is equal to 60 degrees. You could also write it as pi over 3 if you choose to write it in radian format. So if there are no questions, so does anyone have any questions about this? Okay, then if there are no questions, we will go on to the next review problem.
Okay, so let's see this problem. So basically, we have a triangle. BC is 5. A is, oh, ignore this, I guess. A is 30 degrees. Angle B is, sine B is 0.2, and we want to find the length of a CA. All right, so basically, first of all, let's see. First of all, look at what we have here. So we have angle A is 30, sine B is 0.2. So we know by law of sines that sine angle A, oh come on, over the actual length A, okay, equals sine of angle B over the actual length B. Note, by our given definition, we have this is 1/2. Oh, oh, okay, fine. I'll just do. So basically, and we know this is 0.2. So basically, we know A over B, equals 1/10. So we know A equals 5. So since we know A equals 5, we want to find the length of CA. Wait, hold on. I think I'm right. Yeah. Wait, hold on. So we want to find the length of CA. I don't think I think I might have got it. Wait, sine A 1. Yeah. So anyways, A equals 5. As we know, CB equals 5. So wait, uh, actually, I think this should be wrong. I think this should be 10. 10. Okay, so anyways, we know A equals 5, so B should equal 1/2 because A equals 10 in B. So basically, that's the answer.
Okay, yeah. So then we will go on to the next question. So if no one has, okay, here, let me just, didn't clear out. Okay, now, okay, so if a triangle has side lengths 10, 17, 21, then what is the area of the triangle? So this question, we did not include a graph here because actually the graph is not very important to the problem itself. I can just quickly sketch one out. Just say 10, 17, 21. Okay, so just what formula do you want to use here? Heron. Yes, Heron's formula. So in case you guys forgot, I will write out Heron's formula again. The area is equal to square root S, S minus A, S minus B, S minus C, where S is equal to A plus B plus C over 2. So, and over here, S equals A plus B plus C over 2, so that's 17 plus 10 plus 21 over 2, 38, 48, that'd be 24. So that's the area A. I'll just represent area with an uppercase A here. 24, 3, 14, 7. And that is equal to if we first start factoring stuff out, we can take out the factor of 7, then it's 2, 3, 24. This is 144, square root of that is 12, so 7 times 12, 84. Thus our answer is 84. Okay, no one has any questions about this one, right? Okay. And also, I actually want to quickly talk about another quick proof of Heron's formula. So earlier, Kennan gave us a great proof using law of cosines. So I will give a quick other proof if, like, let's say, suppose you have no knowledge of law of cosines. Okay, so I will just write down the assignments A, B, and C. So I have a question. If I have the side lengths given A, B, and C, and like let's say we're not going to use any trig here, so like we're just going to do a beginner level proof, no trig. How would you find H? If anyone has any ideas, they can just send it to me in chat. Like, what property would you use? The most important thing is that we have two right triangles formed here. Two right triangles. So think about it. What could you do with these two right triangles? And like you do know some properties about the length. Like you're trying to solve for this length, but you do know something about these two lengths, right? These two. That these two add up to C. Wait, what did Pythagorean. Okay, yeah, even that is correct. Pythagorean theorem. Sorry, I did not see that earlier. Okay. Um, so I will set up some variable x. Suppose this is x and this is c minus x. Then by Pythagorean theorem, we have that a squared minus x squared equals to b squared minus c minus x squared equals to h squared. A simple application of Pythag. Then after this, so we directly try to solve this one first for x. Uh, it turns out we can cancel out the negative x squared from both sides. So we just get b squared minus c squared plus 2cx. And this, of course, gives us that uh, erase x equals to a squared plus c squared minus b squared over 2c. Oh yeah, shockingly, it does look very similar to the law of cosines formula because you know law of cosines formula is a squared plus c squared minus b squared over 2ac. So, oh wait, why do you guys think this thing looks similar to this? Like why do you think the law of cosines formula for cosine of angle B? Why would this look similar to X? Let me check chat. We know the sides. Wait, yeah, Sarah, the given conditions are that given the sides are length A, B, C. Yeah, we do know the sides. But like the question is, why do you think these formulas look so similar? They're almost the same. Okay, so the answer as for why they're really similar is because x is obviously equal to like let's say this is angle B. X is just equal to a cosine angle B, right? So of course these would look very similar because they're just a factor of a apart. Okay, so but now past all that. Okay. But now that we have x, we can finally solve for h. H is equal to square root of a squared minus x squared. And that is also by difference of squares equal to a minus x times a plus x. And then finally, the area is going to be 1/2 c times h. So that's going to be 1/2 times c times if you do square root a minus x, a plus x, first of all, what you can, from the bottom, the denominator instantly becomes 4c squared. So first of all, this c squared already cancels out with the c outside of the square root. And then on the top, this becomes a plus c. If we take a look at a plus x, what does a plus x look like? That's a squared plus 2ac plus c squared minus b squared. So that's a plus c squared minus b squared because a squared plus c squared plus 2ac is a plus c squared. What about a minus x? Then over here, this actually looks like b squared minus a squared minus c squared plus 2ac. Or this is also just b minus a minus c squared. Okay, so over here, I will first extract the 4 out. So this becomes 1/4 square root of, oh yeah, and then we have to take difference of squares again. A plus c squared minus b squared, that's a plus c minus b, a plus c plus b, right? What about this one? Because this thing is actually b squared minus a minus c squared. So thus it's b minus a plus c times b plus a minus c. I'll just move it up here to write. So 1/4 a plus c minus b, a plus c plus b, b minus a plus c, and b plus a minus c. Then if we just move that 1/4 back in, then we get a plus c minus b over 2, a plus b plus c over 2, b plus c minus a over 2, b plus a minus c over 2. And yeah, this actually perfectly matches Heron's formula, right? Because this is equal to s, this is s minus a, this is s minus c, and that is s minus b. So this is also another way to prove Heron's formula if you don't yet know trig. Okay, so then we will move on to the next problem then. Okay, the perimeter of a triangle is 12 times. Okay, wait, let me see. Yeah, so first, try working on this problem a bit. But if anyone has any ideas, you can send it to one of us in the chat.
Um, all right, so a hint for this problem. You can write out the given condition uh, in terms of the side lengths of the triangle and the signs. And since the law of sines relates the side lengths of a triangle and the signs, you can try to um, create a similar expression using that and see what it gets you.
Oh, Sarah, you got that A is equal to 30 degrees. Actually, um, I'm not sure if it's necessary to actually solve for the angles, but still, wait, would you mind explaining how you got A equals 30 degrees?
Wait, do I just like say it or do I like type it in the chat?
Oh, I mean, like whichever one is whichever one you feel more comfortable with. Like you just quickly, like you don't have to say the whole thing, just give a quick description.
Hold up. Can you hear me?
Yes.
Okay. So first, like you have to write down the equation. So like the perimeter is a plus b plus c, and then you have the average of the signs, sine a plus sine b plus sine c divided by 3. And then the problem also states that the perimeter is 12 times this average. So like a plus b plus c equals to 12 times sine a plus sine b plus sine c divided by 3. And then simplifying the side, you get a plus b plus c equals to 4. And then like parenthesis sine a plus sine b plus sine c. And then you have to connect it to the law of sine since you like have all the sides kind of. And then yeah, so you get the law of sines, right? And then you can get a is equal to 2r sine a, b is equal to 2r sine b, c is equal to 2r sine c. And then you have to substitute and like solve for the circumradius, which is r. So 2r sine A plus 2r sine B plus 2r sine C equals to 4 parenthesis sine A plus sine B plus sine C. And then you just like factor out 2r on the left side. So like 2r parenthesis sine A plus sine B plus sine C equals to, 4 parenthesis sine A plus sine B plus sine C.
Yeah.
And you can get 2r is equal to 4 is equal to r equals to 2. And then now you can find the possible measures for the opposite angle. And then like if one of the sides is 2, then 2 divided by sine A is equal to 4, which means sine A is equal to 2/4 is equals to half. And then I just like thought it could be from 0 to 180. So then like A is equal to half, so I just meant A equals to 30 degrees.
Okay, yeah, that is like almost right. So
No.
I got that A is 30 degree. So actually, you got that sine A, or like, okay, let's say if we close angle A, then sine angle A is equal to 1/2. But in fact, there are actually two solutions to this. Angle A equals 30 degrees or 150 degrees. Yeah, just like a quick heads up. Yeah, you have sine x is equal to sine 180 minus x. So generally, you have like two solutions for stuff like that. Yeah. Okay. So then if no one has, so I think that was pretty clear. That was like a pretty good explanation. So like, okay, yeah, we did not need the blank slide. So then I guess we move on to the next thing. Okay, well, so now the new concept is going to be polar coordinates. So they are different from rectangular coordinates. Oh yeah, and from now on, we call the usual coordinate system where I do like this is x, this is y. We're going to call this like rectangular coordinates, not so that we don't confuse them with our new system of polar coordinates. Okay, so first like you guys can quickly read through it. So polar coordinates are of the form radius theta, like as in they give you the radius. Radius just means distance from origin. Theta is just angle like from counterclockwise. So when they say like you have an angle theta equals to, so what they really mean by theta is you start from the x-axis, you go counterclockwise theta degrees counterclockwise. So then this is going to be where your point is going to be on. And as to determine where exactly your point is, you use the radius r, right? Because you fix this so that now this radius is length r, and this is now your point. Okay. So I hope that was a clear explanation, but like of course we'll have to do some exercises to get used to this. So why don't you guys like first try doing these exercises? Like I do you guys have annotation permissions? If you oh wait, I'll label these points A, B, and C. So if you guys have annotation permissions, just draw them on the board. Like draw where you think they should be, where each of A, B, and C are. Oh wait, can you guys annotate? I think you guys can, right? Wait, yeah, you guys should have permission. Does anyone want to try? Anyone? Okay. So if no one wants to give this a try, okay. So I'll first go through the first example, A. So what exactly is 0 degrees? First one, 0 degrees, and I believe this one's actually simpler because it's labeled on the graph. This is theta equals to 0. Theta equals 0 is literally the x-axis. So you go 2 units along the x-axis, and we have a scale here. Wait a sec. There's already a scale over here, 0, 1, 2. So we just go 0, 1, 2. And here is our point 2, 0 degrees. So this is point A. Okay, so now the rest of you should also give it a try. What are points B and C? You guys can just directly draw on the whiteboard. Okay. B and C. Yeah, that looks right. Yes. Is that 5? 1, 2, 3, 5. Yeah, that is 5. Okay, so I'll quickly explain how you do these. Oh wait, no, this should be here. Yeah. So basically, the 130 degrees, you first go 30 degrees counterclockwise, right? This is 30 degrees counterclockwise, also conveniently labeled over here. Then you go 1 unit along this axis. So 1 unit, so it's right here. Next, 575 degrees, go clockwise 75 degrees clockwise. So you know that your point is going to be somewhere along this axis, right? Then in order to determine exactly where it is, you go 5 units along the axis. So from here, 1, 2, 3, 4, 5. So this is going to be your point right here. So hopefully no one has questions about this. Like, it's very important to get this clear because this concept is going to be like the rest of this entire section is going to be all about this. So I'm just a bit worried because you guys haven't been responding. So wait, actually, I'll just quickly give a few more exercises to see if you guys like understand. I'll just write down some more stuff. Okay, so let's say 6 300 degrees, 4 75, 1 180 degrees, and okay, I'll also give one -1 345. Great. Okay, guys, let's try to do these now. Call these points A, B, C, D, and label them on the graph. So which point is that you're in? Yes, that is point C because that is we go 180 degrees counterclockwise. So then we're basically now facing in this direction, and then we go 1 unit along here. Yes, that's good. So I will erase point C because we have done that one. Point A, 6,300. Okay, yeah, good. Because we have okay, Yoren, I think you understand it. So and also like I'll leave other people who can't so like also do these. Just have to make sure everyone understands these. Okay, so Yoren, you did pretty well with these. So yeah, this is 300 degrees. Then you go 6 units along here. So yeah, right here, point A. Uh, so we're done with point A. Point B, 75 degrees, and then 4 units like that. Yes. Okay, so now what about someone else other than Yoren? What about try this one now? What about point D? Oh, sorry, this one may actually be a little bit tricky if you haven't learned it yet, but okay, just give it a try. Like just tell me, like you can give a wild guess. What do you think it is? 134. You fan. Okay, yeah, that is good. Yeah. So because if you think about we start from facing in this direction, we turn a whole 345 degrees around. So we are now facing in this direction. So imagine you're facing in that direction, but then you go -1. So -1, what is negative? It basically means instead of going forward, you go backward, right? So from here, you go backwards 1 unit, and that brings you right here. Okay, so yeah, good job. I hope you guys understand the concept now. This will be very important, and yeah. So on to the next concept.
Oh, so this is polar coordinates. So I think you should already know Cartesian coordinates, which is like regular x, y, and coordinates, you know. But basically, like for example, we have a y-axis and we have an x-axis. This is Cartesian coordinates. But polar coordinates are kind of different. So basically, they're in the form r of theta, r and theta, where r is the distance from the point to the origin, and theta is like the angular coordinate. Basically, so for example, I have this point. Uh, this length would be r, and this angle would be theta. So basically, and wait, oh, I think this should be counterclockwise, although I'm not sure. But okay, but anyways. Oh no, because these diagrams are counterclockwise. But anyways, connecting the origin from the x-axis to the line connecting the origin and the specified point, aka this point. So basically, if you were to convert it to the rectangular coordinates, we would get this as, oh wait, as suppose like this, oh, uh, okay. So this is r, okay, and this is theta, then the y-axis, I mean the y-coordinate would be y sine theta, as this is theta, and by definition trigonometry, this is r sine theta. Similarly, this is r cosine theta. So this is kind of a way to like convert Cartesian coordinates to polar coordinates. And then proof of why this is true, I just proved it. As I said, it's basically by the definition trigonometry, as if we have a right angle here, right triangle, and we have an angle theta, magnitude r, then the y-axis is r sine theta, and the x-axis is r cosine theta. Like, kind of like think of it as r as the vector's magnitude, like theta is like the angle from the vector to the x-axis, I think.
Okay, yeah. So that's basically the explanation of why why your point would be at that, like why the translation from polar to rectangular coordinates looks like this. Basically, your point r theta is actually equivalent to this in the rectangular system. Okay, so next we will talk about, okay, yeah, this okay, sure. Let's see. So next, we'll just talk about yeah, some more concepts about polar equations, polar coordinates. Yeah.
Okay, so we found a way to turn polar coordinates into rectangular coordinates. So here are some examples so you can uh like try them. So for this first example, we have this would be r, and then this would be theta. So 2 comma 45 degrees would correspond to 2 cosine 45 degrees and 2 sine 45 degrees. And cosine 45 and sine 45 degrees are both root 2 over 2. So if you plug that in, that gives you root 2 comma root 2. So you can see here. 2 comma 30 degrees is similar. We have 2 cosine 30 degrees and 2 sine 30 degrees, which if you evaluate gives you root 3 comma 1. Okay, so you can also find that r comma theta is actually the same point as negative r comma theta plus 180 degrees. And intuitively, this is because, as Alex explained, it's like you go halfway around the circle, and then you go backwards instead of forwards. But formally, you would write this as so r comma theta corresponds to this as we showed, which means negative r comma theta plus 180 degrees would correspond to negative r cosine theta plus 180 degrees and negative r sine theta plus 180 degrees. And if you recall, this is actually just negative cosine theta, and similar for sine. And if you multiply them, you find that they are actually the same point. So that's why that's true. All right.
Yes. So okay. So yeah, that is why this is true. Okay. Not really much to talk about here. Then next. Okay, so this is actually just going to be practice. Convert each of these to rectangular coordinates, and you can type the answers. Yeah. Wait, if anyone has the answers, you can just directly type them into the chat. This is just done by using the earlier thing. Remember, all theta degrees is equal to all cosine theta, sine theta, all sine theta. Well, this is the rectangular representation, and this is polar. Oh, okay, someone got the answer. Let's check. Number one is 4. Okay, yeah, that is correct. For the first one, yes. Okay, yeah, two people have got number one correct. This is equivalent to 4 squared 3. And that's because it's 8 cosine 60, 8 sine 60. Okay. And that is going to be 8 over 2. Other one is 8 root 3 over 2. So that's just, yeah, 4 root 3. I have a question. How familiar are you guys with the like sines and cosines? Like, do you guys have like these things memorized? For instance, like let's say sine 30. Wait, actually, do you guys have sine 30, 60, 90, etc. all memorized? These things, and also like try to memorize tangent 30, 60, 90, etc. Uh, well, cosines, well, those can be directly derived from sines. But either way, I know so you guys took some time for this. So I would recommend like memorizing these because these are some like important facts to memorize. They're like very useful in school math, also useful in competition math. Okay, so and also once you have these memorized, there might be some slightly more obscure facts which you might want to memorize as well. For instance, sine 36 and sine 75. These occasionally come in handy. They can be like derived by yourself, but I would recommend also memorizing these later after you finish memorizing these. Yeah, if you start memorizing these little by little every day, it'll like greatly increase your calculation speed. Okay, now next one. So we already finished this one. Does anyone have the answer to number 2? Oh, someone answered. Number 2 is -6, -6 root 3 looks right. Yes. Okay, yeah, that is right. -6 root 3. So think about it this way. So you have negative, you go around negative 120 degrees. So then you're like right here, right? And this is length 12. So like one quick way of thinking of this is, well, you see this has to be 6 root 3 and that has to be 6. So your coordinates are -6 root 3. But either way, yeah, this is the right answer. So then we will go on to the next one then. Let's try doing these. Actually, for these, I'll add on a few exercises as well. Okay, so now let's try doing these. If you guys have the answers, you can type it to Kennan.
Oh, I think I got an answer. Let's see. A prom one is, let's see, 290 degrees. Yes, that's correct. Because we can just draw out. It's just on the x-axis. Is anyone doing number two yet? Okay, I got a few answers. Let's see. I think all of them though I got were so for part one, let's start for part one. The answer I got was 290. That's what I got. And yes, this is correct. Also I got several answers for prom two. This I think they were all 2 square root 3, 30 degrees. Yes, this is also correct. Anyways, a general explanation of why. Let's see, like for part one, 0, 2 is on the x-axis, so it'd be like here, and then this is length 2. We yeah. So basically, hold on, let me check. Wait, sorry, sorry, I mean the other way. It's on the y-axis. So yeah, so it's over here. So this is 0, 2, and note that this angle is 90 degrees, and note that this magnitude is 2. Uh, so basically, yes. So basically, this is correct. This is 90 degrees. And for this part, no, we have like a 30, 60, 90 triangle. Okay, so like, let's say for this point, this is 3, and this is square root 3. By 30, 60, 90 triangle, this is 30. And we know this is 2, 2 root 3. Yeah. So basically this is 2 root 3, 30 degrees. And then yeah, so I think both of them are correct. Let's see. Yeah, let's have a break now.
Okay, so 5 minute break. We'll come back at 7:53 then, and we'll continue doing these problems. Oh, okay, it's 7:53, so we should get back from break. Um, yeah. So then let's move on to the next problem then. If you have your answers, send them to Kennan.
I'm not sure if you have solved 3 and 4 yet. There are these problems.
Okay, we'll give you one more minute to work on the problems.
Oh, I got. I'll just talk about it. Okay, so I got one answer for three, so which is nice. Let's see. Note each one has two. Yeah, I'll just okay. So for three, I got one answer that is of 180 degrees. Yes, that's correct. That's because we have -5 here, which is like this point over here. And note this is like 180 degrees. So yes, that's 180. This let's look at a three -3 root 2, 3 root 2. So I'll erase this. This one, if you graph it out, it's literally just this point, this over here. So, so basically, this is 3 root 2. This is 3 root 2. So, but it's a 45. Oh yeah, I got it. So let me check. Uh, yes. So basically, this magnitude is 6 because we can have a 45 90, and then note this is 135 because it's a 45-degree angle. So yes, this is 6 135. As looking for part 4, I think. Part 4 we have 10 10. I'll just do it. Okay. So this is 10. This is 10. So this is an isosceles right triangle. So this is 10 root 2. It's a magnitude here. And then note its angle is just 45. Yeah. Oh yeah. So yes, this is correct. This is correct for a number 4 part 1. Okay. And then for part 2, we don't really have a really specified angle. So we just have this as like 3, this as 4. And then note that it's a 3 4 5 triangle, so its magnitude is 5. So uh, this is 5. Then we want to find the angle. So we know its sine is 4/5, or like or it's like a cosine is 3/5. So either way, arc sine 4/5 or arc sine 3/5 or arc in like 4/3 should work. So I'll just do arc sine of 4/5. And I think this should be it for this problem.
Okay, so I hope everyone understands these proofs. Then we will move on to the next problem. Oh, okay. Actually, number 1, we already did that one, so let's skip. Um, I believe I've already explained that quite a few times. So how about number 2? What is the graph of theta equals 20 degrees? Just describe its shape. Is it circle, line, I don't know, or like curve, parabola, whatever. If you have any answer, you can just type it to me. There's one answer. It was a straight line passing through origin. Yes, it is. So the reason it's a straight line is because theta equals 20 degrees, so all points on it all must all be on this line. Do you guys agree? Because that's like the definition of what theta is. All points have to be on this line. Okay, so next problem then. What about number 3? How do you represent this? Does anyone have any ideas? Yes, they're all infinite. So Sarah, would you mind typing out the like all representations? Like just tell me what form are they in? Does anyone have any ideas? Yeah, just as in a like formula, like what do they look like? Yeah. Yeah, that is. So either way, since you guys might not fully understand what I mean for problem 3, point zero 0.01. Well, the easiest way you would think of representing this is, right, it has radius equals to 1 and theta equals 90 degrees. But of course, as I mean, they've said there are like infinitely many ways. And first of all, one of these infinitely many ways is 190 degree plus 360 degrees times k. I hope you guys agree with this because 90 degrees plus 360 degrees times k is just like equivalent to 90 degrees because if you do another 360-degree turn, you come back to the same place. Actually, sometimes it would be better to represent it as to represent it in radian format because this is more common. So I'll just represent it in radian format. Okay. Then there's a second way. The second way is to represent it as -1, -90 degrees, -1, -9 degrees, and then of course you can do plus 360 degrees times k. Um, okay, so let me, so -1, -90 degrees, why does this work? Because look, if you want -90 degrees here, and you want -1 units, so you still come back to this point. Or in other words, you could also write as -1, -pi/4 plus 2 pi k. So the set of all points are just all points of one of these two forms. So yeah. Well, I hope you guys understand this because, well, yeah, this will also be used later. So, okay, so next we'll be talking about polar equations. Polar equations, so I believe you guys have probably done parametric equations before, or actually maybe not. So, but either way, polar equations are one type of parametric equation. Wait, how many of you know what parametric equations are? Uh, Okay, yeah, you know what? We can go into that later, but let's just first talk about what polar equations are then. So uh, what polar equations look like, they are usually a relationship between the radius r and the angle theta. And they consist of all points that satisfy this particular relationship between r and theta. Because for instance, if we think about the relationship r equals theta, then if we start from, let's say, r equals 0, theta equals 0, then what happens is as theta increases, you're like turning counterclockwise. As r increases, your distance from the origin increases. So thus you're turning counterclockwise while increasing distance from the origin. So it looks like this, right? Because as you can see, the distance to the origin is slowly increasing while you're also turning counterclockwise. This is just a basic example. O equals 3 is the equation of a circle centered with radius 3 at the origin. Why is this? Because when the radius is 3, all points with radius 3, every point has distance. Wait, what happened? Okay, every point has distance 3 from the center. This is the definition of a circle, right? All points with equal distance to some point. So yeah, that's why O equals 3 is so this is why R equals 3 is a circle centered at 0, 0. So what about R equals 1 over cosine theta? So over here, I already wrote down what it is, but can someone explain why it is the vertical line at x equals to 1? Like come up with an explanation. Like it doesn't have to, like, I mean, maybe you don't completely understand right now, but, or just come up with ideas. What relationship does 1 over cosine theta have with a line? Wait, hint, turn it into rectangular form. Try doing rectangular form and see what you get. Danny, if you guys have ideas. Okay, then in that case, I will just get into it. So let's talk about why this works. The formula is so points of the form 1 over cosine theta degrees. If you write it in rectangular form, then what you'll get in rectangular form is 1 over cosine theta times cosine theta, which is 1. And then meanwhile, the y coordinate is sine theta over cosine theta. Sorry, okay. Sine theta over cosine theta, this is actually just tangent theta. And as you know, tangent theta, it can range anywhere from negative to positive infinity. So thus, this is actually just going to be all points with x coordinate 1, and the y coordinate can range anywhere from positive to negative infinity. And this is the definition of a line, right? Because x equals to 1, we all know this is the line that looks like this. Okay. So then next. Okay. Okay, so next we'll be talking about how to transform polar equations into rectangular equations.
Okay, so to transform a polar equation into a rectangular equation, you typically want to eliminate you want to eliminate r and theta so you can have something in terms of x and y. And probably the most common way to do this is using y equals r sine theta, and also x equals r cosine theta. So for this example, we have r equals 4 sine theta, and since r is the magnitude, we have r equals root x squared plus y squared, which implies r squared equals x squared plus y squared. So x squared plus y squared equals r times r, and replacing this second r with 4 sine theta, this equals 4r sine theta, which then equals 4y. And then you can turn this into x squared plus y minus 2 squared equals 4, which, if you recall, is the equation of a circle. So this is an example of how you would do that.
Okay, so basically, what you'll then do is, yeah, you do this and then you can complete the square. Wait. Okay, so then, wait, actually, let's move on to the next slide then. So I hope everyone understands this one, because this is very important to how you'll later be solving equations like this. So try solving this one. Like, use a similar technique to the earlier one. If you guys have any ideas, you can chat it to one of us. So, either me, Justin, or Kennan. Does anyone have any ideas? Hmm. Okay, then in that case, I'll just start talking about the method for doing this. All squared is equal to all cosine theta. Can someone tell me what these two sides of the equation are? All squared, what is it equal to? Okay, then in that case, I'll just get into it. So all squared, this is equal to x squared plus y squared. All cosine theta is equal to x. So in other words, x squared plus y squared is equal to x. This can also be written as x minus 1/2 squared plus y squared is equal to 1/4. And also, so now can someone tell me what the graphic representation of this would look like? Okay. Okay, so then if you guys don't know, okay, so I'll just have to go into this really quick. So x minus 1/2 squared plus y squared. So as you can see, this is the equation of a circle. It is centered around the point 1/2 0 with radius 1/2. So thus it is a circle like this. Circle's radius 1/2 centered around 1/2 0. I hope everyone understands this because this will be like basically a homework questions later. Okay, so I hope everyone understands.
Alex, can you quickly explain why this is like a
I
circle?
already did. This I think that was covered earlier.
I'm not sure if it's covered. I don't think the
Probably covered
conics.
in the previous classes.
Okay.
Okay. So then let's move on to the next question. Wait, but wait, I hope you guys like the main point is not about whether it's a circle or not. The main point is how you arrive at this equation. Basically, you have to multiply by all of them. Like you try to somehow turn all into some form of x and y. And in this equation, what we did was we turned it into some form of x and y by multiplying by all on both sides. But basically, you want to apply this method to polar equations. So I hope you guys understand this one. So if you guys understand it, we can move on to the next. Yep, this one.
But hold on, I'll wait for people to solve this one.
Yeah. Okay, yeah, I think we should probably just start going over how to do this one then.
Okay. Yeah, I don't think I got any search. Okay, but anyways, so let's see this problem. So we have r equals a 4 minus 1 4 over 1 minus cosine theta. So first of all, let's transform this into rectangular coordinates. So now we have x equals no, we have r equals x squared plus y squared. Oh shoot. And cosine theta is basically equal to x over r basically. So basically you can plug it in later. But anyways, we get x squared plus y squared equals 4 1 4 over 1 minus x over r. So basically, that means so let's square both sides. So I have x squared plus y squared equals 16 over 1 minus 2x over r plus x squared over r squared. So basically, let's multiply. So if we multiply these two, so basically we get r squared. Let's turn this. I'll turn this back into r squared. So r squared minus 2xr. Add x squared. Basically equals 16. Okay. And then now wait. Oh, actually, no, okay, I'll erase this part. But still note that r equals x squared minus y squared. So note this means that r minus x squared equals 4. So basically, now let's move this. Wait, no, sorry. Hold on. R squared. No, I'll just turn this into rectangular coordinates. So this is x squared plus y squared minus 2x squared. Wait. All right. So we get this equation. Wait. Or actually, wait. Let's. Oh no, I mean, yeah. Let's probably just do it this way. R minus x equals plus 4. So, so this means that x squared plus y squared minus x equals plus. Okay, so then I think it's better if we just move it to this side since we would only have to square once. So we would have x squared plus a y squared. Wait, yeah. So x squared plus y squared equals x squared plus minus 8x, but certainly plus 16. And you see this turns into a quadratic equation as we can cancel out these x squares. And now we get y squared equals plus minus 8x plus 16. I think that should be right. It's basically what? Oh, sorry. I should probably express as parabola in the form of y because we have x equals x equals minus 2 divided by 8 plus minus y squared minus. All right, so basically we get a parabola here.
Okay, yeah, so we do indeed get this equation. Okay, and also I just want to quickly say that is a so if you're unable to solve equations like this directly, sometimes you could just choose to bash them out. I mean, this equation turned out to be nice because you had the fact that you could turn it into all minus all cosine theta equals to 4. and that this side is x, so then you can turn it into x squared plus y squared equals 4 plus x squared. But sometimes equations aren't necessarily so pretty. So for the so-called like less pretty equations, you'll want to do a bunch of substitutions. And usually, so since most polar equations involve all cosine theta and sine theta, so you want to be able to replace cosine theta and sine theta completely with x and y. So can someone tell me how you would replace cosine theta and sine theta completely with x and y? Let's just start with cosine theta. How would you do that? Does anyone have ideas? Okay, is everyone sleepy right now? Okay, but like if you have any ideas, just send it to me in chat. Or like even if you don't have the full thing, just give me the starting point. Like what do you think you should do next? Uh, does anyone else have ideas? Like you guys don't need to be afraid of being wrong. Just like give any idea that comes to mind. Okay, does anyone else have no ideas? Okay, fine. So I'll just say, cosine theta, you know, it's x over r. This can be directly written as x over root x squared plus y squared. Sine theta is y over r. This is y over root x squared plus y squared. Right. So this is how you represent cosine theta, sine theta, and all entirely in terms of x and y. So that like sometimes if you don't find any like easy or beautiful way to resolve the question within like a couple steps, just plug these in, like simplify the equation, and you'll like eventually get it. Okay. Next problem. Using the techniques we've learned so far, does anyone have ideas? Okay, let's see. Wait, Sarah, you said negative one half, one half. What does that mean? Like we're talking about an equation. This isn't a single point. Oh, okay. I mean, that point probably does satisfy the equation, but we're looking for all points. in the locus of this. Does anyone else have ideas? Okay, so if you guys don't have any ideas, I'll just start talking about this. All squared. Okay, so let's first. All is equal to sine theta is y over all. Cosine theta is x over all. This gives us all squared is equal to y minus x. Thus x squared plus y squared is equal to y minus x. Then we can change this into the other form. I mean, completing the square. Y minus 1/2 squared is equal to 1/2, which is also equal to 1 over root 2 squared. Okay. Does anyone have questions about this? Like, because I noticed that you guys have stopped responding, so I'm just like worried that you guys don't fully understand the concepts. But do you guys understand how I managed to transform it from here to here? Just like go through it and verify like each step. Yeah, okay. Sure. Okay, then if you guys understand this one, then let's try the next. Okay, just give this one a try. Remember what I said earlier, if you really can't find any good way to resolve it, then you can just directly replace cosine data and sine data with the x and y representations in bash. Okay, wait, let's see. Yeah. Okay, so maybe like we're going a bit fast. Oh well, but okay, so let's just break this down slowly then. So R squared, can someone tell me what this is? How to represent R squared in terms of x and y? Okay, let's just start with x squared then. This one should be a formula we're familiar with. If you think about it, this is R, this is x, and this is y. So what is the relationship between R, x, and y? Okay, let's see, R, x, and y. Yeah, R is the hypotenuse, so by Pythagorean, we have that R is equal to square root of x squared plus y squared. So R squared is equal to x squared plus y squared. Then cosine theta, remember, since this is theta, so cosine theta is equal to x over r, or you can also write as x over square r squared plus x squared. But then oh sorry, I mean y squared plus x squared. Yeah, r squared of y squared plus x squared. But then what you get is x squared plus y squared square root x squared plus y squared equals to x. Or you could also write that as x squared plus y squared. If you like square both sides, you could get this is equal to x squared. Either way, for this equation, we can just transform it into this and leave it like this. This one doesn't necessarily have a very good form, but wait, this next one will. Okay, so let's just think about how would we use a similar method for this one. This problem should be similar to our previous problem. Do you still remember? It was that it's very similar to this one. Okay, so for this one, how would you do this? Um, oh, sure, yeah. I'll also like write down the formulas. Okay, so here are the formulas for you to remember. Cosine theta. Okay, So I have written the formulas on the whiteboard, so you guys can take a look. Okay, well then I'll just go and explain this one. So first of all, I will multiply this. I'll take this to the other side. This then gives us a 3r minus all cosine theta. Remember, all cosine theta is equal to x. So then 3r is equal to x plus 3. 9 all squared is then equal to 9 times x squared plus y squared equal to x plus 3. And this is basically the rectangular equation. And if you want to, you can complete the square, but you see this is the equation for a circle. Okay. Okay, well, I hope you guys like understand this because the homework will like involve quite a few questions like this. So yeah. Yeah, these problems are basically algebra problems. Converting between polar equations and rectangular equations is pure algebra. Yeah, and like you'll probably see a lot of problems like these in precalculus. They might ask you to convert between polar and rectangular equations. Okay. So next we'll talk about transforming rectangular equations to polar equations. Homework, yeah, it will involve this as well as transforming rectangular and polar equations around. Yes, the homework will be posted right after class. Okay, all right. So this will be our last section for today. Yeah, okay.
So wait. Hi. So this is transforming a rectangular coordinates Cartesian coordinates to polar. So it's a lot sim okay. Uh it's a lot simpler than transforming polar to rectangular. So basically, because like there's no arc sine or arc cosine or or like I mean wait, yeah, so on and so forth. I mean, so anyways, if we have any equation any equation y equals f of x, we replace y with r sine of theta and x with r cosine of theta. I think we should have already gone over this before when talking about polar. But anyways, we plug it in a simplified equation. So yeah, this is an easier example. This is the unit circle. We can plug it in. So we get this, and then we it's basically a lot simpler. We can combine cosine squared theta and sine squared theta. Basically, simplifying, we get the radius is 1, which is a unit circle. 1. Earnings. Okay. 1. Can you switch the slides?
Yes.
Oh, so we have, wait, hold on, how many? We have some practice prompts. And I think you should just send them to me. You should, let's see how long. One, yeah, send me the answers when you're done with this prompt.
Okay. Actually, I'll write all the prompts on the same slide. So wait, this is problem 1, this is problem 2. Problem 3 here is 4x squared y equals to 1. Problem 4 is y equals -3. Problem 5 is y squared equals to 2x. And the hints will just be x is equal to r cosine theta, y equals to r sine theta. So try to turn these into polar form.
I haven't gotten any answers, so I'll just explain this prompt then, I think. So basically, let's look at, let's see. Yeah, let's look at the first one. So the first one is x minus 3 squared plus y squared equals 9. So let's turn this into polar form. So as Alex said, x equals r cosine theta, y equals r sine theta as him. So we just plug it in and we get r cosine theta. Uh, uh, or cosine theta minus 3 squared, plus r sine theta squared, equals 9. So note that note that we have this 3 here, so we can cancel out. So now we get r squared cosine theta Oh, come on. Cosine theta squared plus r squared sine theta minus 6r cosine theta. This is 0. You know this is 0. And then note by Pythagorean theorem we can group these two. Oh wait, sorry, I forgot this. We can group these two. It becomes r squared. So we know r squared equals 6r cosine theta. And then assuming r does not equal 0, even if it's 0, just be the origin. But we can cancel out. Yeah, we can cancel out this, and we get r equals 6 cosine theta. Wait, I better write this. Okay, so for the first one, we get r equals 6 cosine theta. I hope y'all understand that. So, yeah, I'll explain number 2 then. Okay, so number 2 basically states 2xy equals 1. Here. So 2xy equals 1. This is more straightforward, I'd say. We just directly plug it in. So we have 2r squared cosine theta, sine theta. This we know equals 1. Although I think we can keep in this form, although let's say I'm not sure I would but either way, we know that. Or I think you can do this. But either way, we have this form equation, I think. And then wait. But anyways, this one's straightforward. For number 3, 3, it's like similar idea. We have 4x squared y equals 1. So let's plug this in. This is 4r squared cosine theta squared times r sine theta equals 1. Combining it, we get r cubed cosine theta squared times sine theta equals 1/4. And I think this should be it for this one. And then y equals -3. Well, y equals -3 is a straight line. It's basically, we can just plug this. Wait, yes, we can plug this in. So r sine of theta is -3. That's the third question. I mean, sorry. This is the fourth question. And then 5 is also simple. This is y squared equals 2x. Yeah. So basically y squared, we get r squared sine squared. Squared sine theta. Alright. So we have r squared sine squared theta equals 2 of x, which is 2r. Okay, 2r cosine theta. I think that's right. So basically we cancel this out. And now we get cosine theta squared equals cosine theta 2 cosine theta. Then I mean, yeah, we could but either way, I think yeah, I don't think you can simplify this a polar equation. So, yeah, I think this should be it for the 5 questions.
Okay, yeah, that's it for all of the questions today. Yeah, so yay, we got everything done. Then now, so this will be the homework. We will also post this in Google Classroom if you, so like just write it down for now. We'll also put it in Google Classroom as soon as the class is over. The recording, we will also post it in Google Classroom as soon as it's like uploaded. And yeah, I just hope everyone like understood a class today about polar coordinates, polar equations, and how to transform between polar and rectangular equations. So yeah. So then, if no one has any questions right now, then I guess, well, good night, everyone. And yeah, we will be holding our office hours on Wednesday where we will go over all of the questions. So if you have like any if you have any uncertainties about how to do the questions, then you can come to our office hours on Wednesday. And then our class after that will be on Thursday, and we will have another office hour on Saturday. So yeah.